Hi everyone, this is Srikanth. Welcome back to my channel. In the previous session we have seen what is JavaScript, synchronous and single-threaded programming language briefly. So in this video series we are going to deep the session by session more about how the JavaScript will work and how it executes and what is the priority and how it behaves when it encounters asynchronous task. So in this session we are going to cover about what is callback and what is call stack. So these are the two important concepts which will help us to understand the upcoming videos. Okay, let's see what is callback. A callback is a function which is passed as an input to the another function. There it will be get executed. So let's see with an example. As I said, callback is a function which will be passing as an input to the another function. Okay, so let's take function A which will print console.log. Simply it will print console.log A. Okay, and let's take one more function B, console.log B. Okay, see now I'm executing function A. Okay, and I wanted to pass function B as an argument to function A, and we'll have to receive this is nothing but callback. Now we will execute this callback inside the function A. Okay, now let's run this and see the output. See, if you see in the right side section, we are calling function A by passing function B as an argument to it. Okay, and inside this callback A, call function A, we are executing the callback which is nothing but the function B. That is why it got printed here B, and then it is printing console.log A which is belongs to function A. So this is nothing but the callback. If you see the same example here, in the previous session we have used set timeout. Let's say function C and take set timeout. Okay, so here you can see we are taking this anonymous function as a callback. Okay, and let's print console.log C. Okay, even if we take it as a 0 to execute, seconds to execute, let's say call this function on top of function A. So the execution order will be, let's run this one. So if you see here, even if we are calling this C before A, so you're still printing B which is a callback function, then A which is present inside the A function, and the C always prints at the bottom, because as we discussed in the previous session, the JavaScript, whenever the JavaScript sees this set timeout, it will simply hand over to the browser and ask the timer to start. So browser start the timer. Once the timer is completed, it will again notifies back to the JavaScript. Okay, so what exactly happens when it comes back to the JavaScript? Will JavaScript execute directly? No. Instead, it will place this set timeout into the micro task. Okay, so we have two concepts called micro task and macro task. So we'll discuss about these things in detail in upcoming sessions. For now, I'm just giving a heads up like how the set timeouts will execute. Many people will think that the JavaScript will wait for this one to execute. here the thing is JavaScript will not wait for it. It simply handovers to the browser. Browser notifies back to it. So meantime JavaScript will continue executing other functions. So that is happens behind the scenes. Okay. So now we'll see order BAC has printed. So in this one I wanted to clarify you what is callback. So with this one, a function which is being passing to another function as an argument is called callback. In this one we can say this anonymous function is a callback. So once this is completed, the timer is completed, this callback function is placed into the macro task. From there event loop will fix it based on the main thread availability. Once the main thread becomes free, event loop will look for this micro task and macro task. So in these two things, micro task will contain what we can say async await related, and fetch, and then. So this will be having high priority than macro task. So event loop chooses micro tasks before macro task. So if we take an example of macro task, set timeout is the good example for this macro task. So here as we seen set timeout. So in our example as we have seen set timeout. So once the timer is completed, browser notifies back to the JavaScript, and JavaScript immediately will not execute it. Instead it will place into the macro task. So once the event loop checks for this main thread is free, then it will look for this callbacks inside the macro task. So once the main thread is free, it will push these things into the call stack. I hope this callback concept is clear. Now we are moving into slowly call stack. So what is call stack here? See, call stack is nothing but the function JavaScript keeps track of functions which are being executed. Okay, so call stack follows the data structure called LIFO, last in first out. Okay, the call stack follows this data structure LIFO, last in first out. So let's say I'll try to show you how it looks like the call stack by drawing in this one. Okay, so let's assume this is a call stack. So let me increase the font size to some 14, 16. Okay, so here if you see call stack, let's assume this is a call stack. So initially the JavaScript itself JS execution context into the call stack. It starts by pushing JS execution context into the call stacks, which will helps to execute the JavaScript code. So let's say JS execution context. Okay, this is at the first, which will push into the call stack. Next, which this will help us to execute the JavaScript code. And see, if you see in this order what we are executing, see first is being executed B. So let's say how the call stack will be starts. Okay, so we are calling function A. Okay, now it will push into the call stack like this. Okay, so inside this call stack A got be pushed into the call stack. Next, if you see inside A, what it will have callback, which is nothing but function B. Okay, inside A what we have function B. Okay, now what is there inside B? Simply it will print the console.log B. So let's say console.log B is printed inside this B function. So here we can say console.log B has been printed. So if you see here B, inside the B function B, only we have one statement, console.log B. The execution has been completed. Now what will happen? It will pops out of this function B as the execution is completed. Okay, now we will have only function A, and what happens? This one. Okay, function A. So just to modify small correction, as we were executing function C first here. Okay, it needs to be pushed into the call stack first. Okay, let me draw it again. I'll show you in more detail. Okay, so I did not see that one. One minute. So here what is happening is, so as I said, first the JS execution engine will be pushed into it. Okay, JS execution context. Okay, global execution context, we can say it as a global execution context. Okay, next what we are executing, function C. Okay, so initially here we need to be careful. Initially it pushes function C into the call stack. Function C pushes into the call stack. So whenever JavaScript comes to this function C, whenever it encounters this set timeout, whenever this sees this set timeout, it will immediately pops out from the call stack. C will be removed, and this function C will be this will be handed over to the browser. It will run the timer. Okay, so once the timer starts, and JavaScript asks like, once this function is completed, notify me. So browser will notify us back once this function is completed. So at that time it will place into the macro task. Instead of executing this directly, what this will do, this will placed in the macro task. Okay, as we discussed, set timeouts will be placed in the macro task. Okay, once the JavaScript main thread is free, this set timeout callbacks will be placed onto the call stack from the macro task. So if you see here, as soon as it encounters, it removes, it pops out. Okay, here it pops out, removed. So now what will happen? We will only having JS execution context, global execution context. Okay, context. Okay, now C has been removed, right? So we will not have the C, because when this is handed over to the browser, once the timer completes, again it places into the macro task, not inside the call stack. Okay, so once everything is finished and the main thread is free, then it decides which one to place, micro task or macro task, into the call stack. Now if you see in this order, C has been popped out and it comes to the A, and what is present inside the, now it will push A into the call stack. A into the call stack. Again, if we go back, what it contains inside A, the first line is callback function, which is nothing but function B. So again function B will be pushed into the call stack. So if you see, function B is pushed into the call stack. What is there inside this function B? It will simply print the console.log B. Okay, so it will pushed into the call stack. It prints, simply it prints console.log B. So console.log B, it is printing console.log B. Okay, now is there anything else that needs to be executed inside this function B? No. So it will pops out after printing console.log B. It will be pops out, and also B. So this function, once this function B is popped out, what we will have left? Only function A. So inside the function A, what it will print? Console.log A. Console.log a. So console.log a. Okay, so this has been printed. So is there anything else that needs to be executed? No, right? So function a will also be popped out. So only JS execution context will remain in same. If nothing is there, this will also be popped out. So sometimes we see an error in real-time programming. Maximum call stack size is executed. So we'll be having here the limit. So if we are keep on running this recursion, like function A, function B inside executing one another in the loop, so the stack size will be exceeded, and that we call is as stack overflow. So stack overflow we will call it as. When this happens, if we are executing some function inside a loop, this situation may come. Okay, a recursive function we can call, which calls itself inside the loop. So now I hope you people have understand what is call stack, what is callback. Okay, so these are the main things which will help us to understand the coming videos, the order how the JavaScript will execute. Many people will think JavaScript will wait for the set timeout to complete. Instead, what it will do, it will just hand it over to the browser and it will continue the remaining task. Okay, and next what we can do in the coming sessions, as we have not discussed in detail about microtask, macrotask, we will try to cover these things in the next sessions. And we'll also see a simple thing about browser architecture. So browser architecture, if we see what it will contain. So first thing, it will contain rendering engine. Okay, rendering engine and JavaScript runtime, so which will be used for executing the JavaScript. Okay, and the storage and the audio video related components and networking and other components. Okay, components. So if you see here, rendering engine is nothing but the each browser will be having an engine, rendering engine. For example, if we take in a Chrome, we will be having V8 engine. In the same way, Firefox, Mozilla and Mozilla Firefox and this Safari will be having their own engines. Okay, so this is the browser architecture. We will discuss in detail about each thing in the coming sessions. And let's say what JavaScript runtime will contain. JavaScript runtime will contain so what is JS execution context and what else it will contain? JS execution context, web APIs, macro task, micro task, as we have just seen macro task. So we'll discuss more about this macro task in coming sessions. And yeah, so let's say this is the JavaScript runtime contains. Okay, which will, if you observe, the same JavaScript code will be executed inside the Node.js, but Node.js will not have the browser, right? So Node.js also provides the JavaScript runtime environment. The same code will be executed in the Node.js, same like the browser will also provide the runtime environment of the JavaScript to run it. Okay, so that's it for this session, guys. So we'll see more in the coming sessions. This topic will get interested and interlinked with other sessions, so try to watch in the series order. So thank you guys for watching. We'll see in the next video.